Okay, hi everyone. So welcome to our H2 Math supplementary worksheet for Chapter 9 functions. And in this video, we are going to run through concept number 8, in which we are going to find the range of composite functions. Okay, so over here, right, what is going on is there's two methods in which we can use to find the range of composite function. Now, the first method is what we call the indirect method, or what we call the mapping method. Okay, so what we do over here is we will be sketching two separate graphs. So we sketch the graph of the first function and sketch the graph of the second function, and we determine the range for the first function and restricting the domain for the second function. Okay, and then we read off the corresponding range. So this involves sketching two separate functions. Okay, so this is the indirect method. Now for the direct method over here, we are going to sketch that composite function itself and observe directly. So when is the indirect method okay? When is the direct method okay? So the direct method is okay if the composite function is very easily determined. Okay, but the indirect method will be useful for very difficult cases where the value of input is very big, right, or like very easily go out of the range, or it's very complicated if you cannot type into the GC and get the graph directly. Okay, so what we need to do is we need to learn both methods. Okay, but in this particular video we are going to focus on the technique for the indirect method. Okay, so with this, let us jump right into example 8 over here, right? So example 8, finding the range of composite function of GF. Okay, so what we're looking for the range of GF. Okay, so what are we going to do over here is first, let us look through what we need to do, right? So GF, right? So first function is function F, second function is function G. So let us draw F first, all right? So F over here is a quadratic function. So it's a positive quadratic function over here. Okay, you can use your GC to help you with this, right? And then the minimum value is should be 3 lah, huh? 3 and then 3 and -1, right? Do you need to really draw with axis? I think this is just a sketch will do. Okay, so don't have to worry about the axis. And then where are we starting? What's the domain? The domain is x less than 4. So we're going to start at 4. Okay, so this one over here is 4, 0. Okay, and what am I going to do is I'm going to erase the part on the right hand side. Okay, so if you want, right, you can even erase the whole thing also, right? And this is the graph that you get. Okay, but I will show you the original graph lah. Okay, so what is going on is now this over here is the domain of F, right? And then this over here would be the range of F. Okay, so first, what is the domain of so what's the range of F? The range of F, right, would be, okay, starting from -1 up to infinity. Okay, so this is the first step. Okay, second step, let us draw the graph of x over x plus 3. So x over x plus 3, right, is going to be something like this. If you do a long division, you will see something like this. Okay, so x is equals to -3, y equals to 1 as your the horizontal asymptote. Okay, so let's take a look at what are our, so what we're going to do is we're going to substitute in or fit in this range of f to this function over here, so that we will restrict the domain of this to just the range of f. Okay, because the values that we are putting in is just the range of f. So we are going to start at this part over here. So what is this? When you sub in -1 over here, what is the value in the function? The function is actually -half. Okay, then right, what happens is on the other side, so we won't be caring about this part. we won't be caring about this part because we are looking at the numbers greater than -1, correct? So over here, let me draw again. So this part over here, okay, if you want to be a bit more exact, this part over here until positive infinity, this is your domain, okay, that you sub in, okay? And then this over here would be the range of GF, okay, the total range of the whole function, okay? So based on this, right, based on this one over here, what is the range of GF? So the range of GF, the minimum value is going to be -half, right? And the maximum value is 1 and we cannot equal to 1, okay? So can you see that it really corresponds to this and this? Okay, so the range is minimally -half equal and maximum is 1 cannot equal, very strictly less than 1. Okay, so this is how we get the range of GF by the mapping method or by doing the indirect method. Okay, so we will sketch individual graphs for F and G and then we will do that. Okay, now so where is this useful? This is really useful if we get this and then we want to substitute it into the function of the rectangular hyperbola, because right, for some parts it will invert the order. So for example, if you put in -1, right, as the maximum point, or sorry, as the minimum point over here, here somehow it just restricts to -1 over here. Sometimes it may flip also, so you need to double check and see it may be maximum or minimum. So yeah, so this one you just need to double check to find out the range of your GF lah, one by one. Okay. Okay, so let's take a look at do it yourself 7. All right. So you can do it yourself first, okay, or you can just refer to this, and as you do, or after you finish doing, then you can come back and check. Up to you, okay. But you try to do it yourself, lah. Okay. So we got two functions f and g. All right. So f is defined for this for a restricted domain. Gx is defined for this for a restricted domain as well. Okay. So let us find the range of GF. So first, let's determine the order in which we want to do. So we've got this, do pass through F first, and then we need to pass through G. Okay, so it is F first, then G. So let's take a look at Fx. Fx, right, the domain is restricted to -1 and 3. So over here, this point over here, this is 0, 0, right? This point will be -1. So if you put in -1, it should give you -1. Okay, if you put in 3, okay, it should give you -9. Okay, and beyond that, okay, beyond these 2 points over here, right, we don't consider the graphs anymore. Okay, so over here, right, you have your domain of F, right? So here would give you your range of F. Okay, so over here, the output from F, the range of F is going to be equals to minimum is -9. Okay, maximum is going to be 0. Okay, can equal for both. Okay, if you notice, so this is how it looks like. Okay, then restricting the domain, right, based on this over here into gx, right? Gx, okay, so let's find where is -9. -9 is actually over here, right? So when x is -9, right, sub in -9 into here, y is going to be equals to ln 82. Okay, now at the same time, when x equals to 0, subbing in here, so here will be ln 1, and ln 1 equals to 0. So actually we've got here, this is 0, 0. Okay, so means, right, for this restricted domain of G, okay, so for the restricted domain of G, right, we are going to ignore the right hand part of this curve. Okay, and based on this, we will need to read off. Okay, let me erase this part also first. Okay, so over here we'll need to read off what is the range of G. Oh, sorry, range of GF. Okay, so the corresponding range of GF is, okay, so minimum value is 0, maximum value is ln 82. Okay. Oh, by the way, I need to pay a bit of attention over here. Now let's highlight something over here. Okay, sorry. Okay, this one and this one, right? So let us take a look again, right? There's a part where I did wrong. Okay, so this one should be an open circle over here. Okay, and because of this, it should be an open circle over here as well. Okay, and then because of this, -9, right? Sorry, -9 cannot be equal. Okay, and because of this, the ln 82, right, also cannot be equal to ln 82. Okay, so this is something for us to take note. Okay, because of this particular inequality over here, the domain. Okay, so something for us to double check. Okay, so like by sketching the two separate graphs, right, and mapping. Okay, what we are doing is we're mapping this range, right, to the domain of the function g, right? So by restricting the domain to Rf, we will get the range of gf, function gf. Okay. Okay, last but not least, for to do it yourself aid, right? So what we do is same thing. We're going to sketch the two graphs and we're going to find the range of gf. So let us look at the process again, right? So the first function that we'll take is f, second function that we'll take is g. So we'll sketch f first and then g. Okay, so the domain of fx, right, is over here between 0 to 3, right? So we are going to start from 0. Okay, so if you notice, right, the full graph is like this. Okay, for the square root graph, is going to be like this. Okay, so I'll just put in the axis for you to refer to so that you can get used to this. So we're starting from 0, 0. Okay, so sub in the 0, the y is 0. Sub in 3, right, the y over here, right? So if this is 3, the y is going to be root 3. Okay, then what I'm going to do is I'm going to like erase this part of the graph. Okay, so over here, this is the domain of f, right? Then over here, this is the range of f. So the first step, range of f would be from 0 to root 3. Oh, cannot equal to root 3. Okay, so this one need to be sensitive. Cannot equal to root 3. So I will need to put a hollow circle over here instead. Okay, so cannot equal root 3. So the domain is can equal to 0, cannot equal to root 3. Okay, so with this, right, let us sub in and let us restrict the domain over here following the RF. Okay, so over here, right, we have 0 over here. Okay, so 0 will give me 0, 0. Using your GC, you can sketch this graph. Now, and then when you sub in root 3, right, at this point over here, at some point over here, you will get 3 and ln 4. Okay, as the coordinate. So what we'll do is we are going to, because this is the restricted domain, so what we'll do is we'll just ignore the other parts of the graph already, or we will not consider the other parts of the graph already. Okay, so it's going to be like that. Okay, so from this restricted domain, what is the range of GF? Okay, so therefore the range of GF, right, the smallest value is going to be 0, bigger value is ln 4. I can equal to 0 and I cannot equal to ln 4. Okay, so this is the final answer for do it yourself 8. Okay, and that's the end of this video. Once again, you can definitely do you can confirm you can do like the direct method of compositing both functions together and then put in the GC and analyze the numbers, right? But what I want to encourage you is for much more difficult questions, right? This skill is very, very useful because sometimes you may not get any image from your GC because the GC window is limited. Okay, so what we need to do instead is we just need to be flexible with using either of the method, the indirect or the direct method. And what we'll do is just sketch patiently. You just need to know the general shapes of each standard graph or standard curve, and you just need to read the domain and range from there. Okay, sub in the values, read the range and domain from there. Okay, so hopefully this has been useful to help you to find the range. Okay, and it's a bit clearer now on what to do. So so we'll end the video here on the section of composite function. In the next video, we're going to start something called piecewise function. Okay, so see you in the next video.